This is a video on solving polynomial equations. Now we know linear equation is fairly simple. It is of the form ax plus b equal to 0, and we know x is equal to minus b by a. This is for a linear equation. Now next we move on to quadratic equations. Degree here you find that equation is of the form ax square plus bx plus c equal to 0. Again, we know that we can compare it with, if two polynomials are equal, their respective coefficients must be equal. If alpha and beta are the roots of the equation, then x minus alpha times x minus beta equal to 0 would imply x square minus alpha plus beta times x plus alpha beta equal to 0. Therefore, comparing the coefficients here, this can be rewritten. If we divide by the leading coefficient, it can be written as x square plus b by ax plus c by a. So comparing the coefficients, we can see that we will, if two polynomials are equal, their corresponding coefficients must be equal. Therefore, you get alpha plus beta equal to minus b by a, alpha beta equal to c by a. Now we know that a minus b the whole square is equal to a plus b the whole square minus 4 times ab. So we can find out alpha minus beta is equal to minus b by a the whole square minus 4 times c by a. Resolving it, we get the quadratic formula, which is the roots are alpha comma beta is equal to minus b plus or minus root of b square minus 4ac by 2a. Now we move on to a cubic equation. We have ax cubed plus b times x square plus c times x plus d equal to 0. Again, dividing this by the leading coefficient, we get x cubed plus b by ax square plus c by ax plus d by a equal to 0. Again, if alpha, beta and gamma are roots of a cubic equation, then the cubic equation can be constructed as this, which is x cubed minus alpha plus beta plus gamma times x, alpha plus beta plus gamma times x plus alpha beta plus beta gamma plus gamma alpha. So alpha x square plus x plus minus alpha beta gamma equal to 0. Again, comparing the coefficients, we will obtain, similar to the quadratic, we will obtain alpha plus beta plus gamma equal to minus b by a, alpha beta plus beta gamma plus gamma alpha equal to c by a, and alpha beta gamma equal to b by a. So we will obtain a this thing similar. Now just as for the quadratic equation, what happened was when we got alpha plus beta, to get one root we have to eliminate beta, so we have to determine alpha minus beta. To get one root we have to eliminate these two roots, so we have to get alpha minus beta plus gamma. Just as for the quadratic equations, we made use of the fact that a minus b the whole square is equal to a plus b the whole square minus 4ab. For this one we make use of the fact that a minus b the whole cube is equal to a plus b the whole cube minus 2b times b square plus 3a square. So this is the simple formula. Now you cannot use quarter squaring there because that will not help. It will only lead to an identity. Because it's a cubic equation, you have to use cube. So now what will happen is, because we are cubing it, there what happens for a quadratic equation, even though we use square, we obtain a linear expression. If we cube it, when the cubic term will get cancelled here and you will get a quadratic expression. So the quadratic equation can be solved. So we can solve a cubic equation in terms of a quadratic equation. So similarly, so we will get something like this. Alpha minus beta plus gamma the whole cube is equal to alpha plus beta plus gamma the whole cube minus 2 times beta plus gamma into beta plus gamma the whole square plus 3 alpha square, which upon simplification will yield alpha minus beta plus gamma is equal to cube root of minus b by a the whole cube minus 2 times beta plus gamma into beta plus gamma the whole square plus 3 times alpha square. Let me write this more neatly here. Is equal to cube root of minus b by a the whole square plus minus b by a the whole square minus 2 times beta plus gamma into beta plus gamma the whole square plus 3 times alpha square. So this we will get alpha minus beta plus gamma. So in general you will get, so substituting, adding, alpha plus beta plus gamma equal to minus b by a. Adding the two together you get this. So and then cube it, right? So you will get, in general, so simplifying it further, you will get alpha plus b by a the whole cube is equal to minus b by a the whole cube minus 2 times beta plus gamma into beta plus gamma the whole square plus 3 alpha square. So you will get this equation. Now if you expand this, it will come to this. It will come to 8 times alpha cube plus b cube by a cube plus 12 times b by a alpha square plus 6 b square by a square alpha is equal to minus b cube by a cube plus 2b by a plus 8 alpha cube plus 2b square by a square alpha plus 4b by a alpha square. So the cubic term here will get cancelled and you will be left with beta and gamma here, which can be expressed in terms of alpha. So you will have only a quadratic equation in terms of alpha. That quadratic equation in terms of alpha is 2 times b by a 4 alpha square plus 4b square by a square alpha plus b square by a square minus 1 equal to 0, which gives alpha is equal to minus 2b plus or minus root of 2b the whole square plus 16 times a square minus b square by 8a. So this will give you alpha. As you can see, there are two roots involved here. Effectively, you can substitute for beta and gamma as one of those two roots of alpha to obtain one more root, which is the alpha itself. So all three roots can be obtained in this way. So now for cubic equation, we have used a minus b the whole cube is equal to a cube plus. Now similarly for a equation of degree 4, which is a biquadratic equation, you can verify it yourself. Similarly, you will have you have to make use of the fact that a minus b the whole square power 4 is equal to a plus b power 4 minus 8 times a square plus b square times ab. You can verify it yourself. For a biquadratic also it can be similarly done. From this, what we can see is, again, you will find that the term involving alpha power 4 will get cancelled, so you'll be left with a cubic equation. So you can solve a biquadratic equation in terms of a cubic equation. Likewise, you can also solve a quintic in terms of a biquadratic equation and so on. So what we observe here now, another alternative approach is also possible. For instance, for a cubic equation, we know how to solve a quadratic. Another approach can also be adopted. So which is that you have an x minus alpha times x minus beta into x minus gamma equal to 0. Again, we have the usual. For this cubic equation, we have the usual thing: alpha plus beta plus gamma equal to minus b by a, alpha beta plus beta gamma plus gamma alpha equal to c by a, and alpha beta gamma equal to minus d by a. So this is the original set. If a cubic equation is true, then x minus alpha, the quadratic equation x minus alpha times x minus beta is also true. So we need to determine coefficients. We are interested. The thinking is there a quadratic equation, the solution to which is the solution to this cubic equation? Assume such a quadratic equation exists and it's actually a dash x square plus b dash x plus c dash. Okay, so again, for this we know that x must be if alpha and beta are the roots of this equation, its for alpha plus beta equal to minus b dash by a dash, and alpha beta equal to c dash by a dash. Now for the first one we saw this thing. So for alpha plus beta we can substitute, and resolving for gamma from the above two we will get the following. Gamma equal to ab dash minus a dash b by a dash, which is equal to a dash c minus ac dash by ab dash, which in turn is also equal to dA dash by AC dash. So now we are not much interested in gamma, but we are interested in these three equations. We can take any two pairs at a time to resolve for three. Those A, B, C, D are known, the cubic equations, coefficients. We determine three coefficients, which are coefficients for the quadratic equation which has to be solved, which satisfies this equality. We can take any two pairs at a time, to solve for a dash, b dash, and c dash, to plug in the values here for that quadratic equation which we can solve, so to get the solution for the cubic equation. Another thing to note is that if we know the root, this is another point to note. Another thing to note is that if we say know the solution to any one root of any polynomial, all the other roots, assuming that the polynomials of a smaller degree, can be solved. If we know the root of any one of this thing, all the others can also be very easily determined. So if we know the root of a quadratic equation, for a cubic equation we can easily determine it. So this tells from this we can see that so if you are someone who is interested in computer science or anything like this, we can see that not only can patterns in the data be used for finding desired processes involving the data, but patterns in the process can lead to finding desired data, in this case zeros of a polynomial. So the relationship between process or computation and data is a fairly symmetrical one, so or somewhat relative mutually complementary one. So there is always data involved in a computation, there is always computation involved in data, so both of them are somewhat interrelated or interconnected in that way. And so the set of all, so this means we can define, say inductively prove it. We know that quadratic polynomial equation of degree 2 can be solved. Inductive clauses in the inductions, this is the basis step. So for an inductive proof, this is the induction step. If a polynomial equation of degree n can be solved, a polynomial equation of degree n plus 1 can also be can also be solved. This is your induction step. So this leads to the final conclusion that a polynomial equation of any arbitrary degree can be solved, provided it is a finite one. So every polynomial equation can similarly be solved. So the solution always often lies in the realm of complex numbers, very rarely in the realm of real numbers. So real number solutions are also possible, although even they are also infinite, every real. But so this is the basic